MBMTC 2024. My name is Dan Kelly. I'm with the Michigan Association of Broadcasters, and we're delighted to have you here for the conference this year, which is jointly presented by Michigan, Ohio, Indiana, Pennsylvania, and Kentucky Broadcast Associations. We expect a great turnout for the conference this year. We're expecting more than 200 attendees, and our exhibit hall, which will be open tomorrow, is full with more than 60 companies exhibiting. I'd like to give a big thanks to our conference sponsors for making today's conference possible. You'll find a list of them in your packets, and special thanks to Gates Air, our presenting sponsor. For those of you who have attended this conference in the past, you know it has traditionally been a one-day event, but we decided to add an additional half day of sessions this year so that we can explore some issues in depth. So this afternoon we have 4 70-minute sessions for you. The sessions will be followed by our welcome reception from 5:30 to 7 p.m. at Moran's Bar and Grill, which is about 2 blocks from here. And then we hope you'll be back here bright and early tomorrow morning at 8 a.m. for the opening of our exhibitor showcases. We'll be giving away door prizes during the breakfast in the exhibit hall. Hopefully you saw the great prizes we received this year on the table outside there. You must be present to win. On to our sessions for the afternoon. The first session will explore the cloud native software architecture and common software foundation and how broadcasters can take advantage of the benefits of a cloud native architecture. Our presenter is Jing Zhou from Harmonic. Jing is the Director of Broadcast Solutions at Harmonic and leads the company's go-to marketing strategy for playout and encoding solutions. He is an expert in broadcast technology and drives Harmonic's definition of key broadcast-related product requirements, positioning, and competitive analysis. Jing has nearly 20 years of experience in broadcast engineering and IT work, including 11 years at Warner Brothers Discovery, where he managed global automation playout systems and business continuity planning, and 6 years at video technology vendors, where he led various solution trials, managed complex projects, and developed technical strategies. Jing, we appreciate your time today. Thank you.
Thank you. Very glad to be here, everyone. So now that you know what I do, and I like to get some information from everyone attending this conference. So can we start from this gentleman at the very first row? Can you give us, everybody, a brief introduction of what company you're representing and what you do there?
Oh, yeah, I'm a CIO, but I'm in radio, not TV.
Okay, what's your name?
My name is Derek Price. I'm from Chicago.
Nice meeting you. Okay, and
Hi, I'm John Fulton from Ideas for the Public Media, and Senior Director of Technology at PBS.
nice meeting you. And
Say Mr. Price, never apologize for your Really safety from Philly, Ohio, chief engineer for radio.
nice meeting you. And
Tim Connor, WCHR Indianapolis.
yes.
Team manager.
Todd Donaldson, WLAN, engineer.
Brian Herla, WTA Earth Television, Pittsburgh, sports specialist.
I see.
Dave Bader, broadcast engineering, Mark Martinez, WGT in Toledo, IT administrator.
Jim Gillen, WLIO, WOHL, I'm Ohio, Chief Operator.
Nice meeting you. Yes, sir.
Radio, Cincinnati, IT broadcast.
Brian Ross, WTOB, still alive.
Aaron Donnelly, TCT Networks, Great Lakes Regional Engineering.
Steve Crum, Vice President of Engineering for Christian Television Network.
Yes.
Mike Meadows, Director of Technology for Michigan.
Albert Brown, WOSU, Public Media, Chief Engineer Radio.
Mark Saunders, Engineer, Nexstar Media, WCMH TV,
It-
Columbus.
Okay.
Jeff Tracy, Wayne TV, Fort Worth, Indiana, that's I'm Brendan Hickman, broadcast engineer, WMTC.
Okay. and the location of your company? I see. Thank you. Nice meeting you.
Eric Workman, Assistant Chief of Engineering, also MBMTC.
Michael Johnson, also BMC1,
Nice meeting you. Thank you, everyone. Very glad to meet you. So, what I want to discuss today is like, does cloud really make sense for broadcasters? And I don't, typically I don't really like conveying one-way street information. I like to make all my sessions as interactive and as engaging as possible. So before we start, I'd like to ask from everybody, do you embrace or does your facility embrace any of the technology-related, cloud-related technologies, either from your station perspective or from a station group corporate perspective? Anybody wants to give some insights?
How do you define cloud? Private cloud, public cloud, or both?
I think both, if you can specify. I know there's a big initiative of putting playout onto public cloud, and then later on, people start to realize the OpEx are when shoot out of board, and it just shoot up to the roof, and then just going back to private cloud and going back to on-prem appliances. So I really want to get a sense of how industry has evolved.
Yeah, we're looking at private cloud, on-prem cloud, basically, for a lot of our services.
Okay, is that playout, encoding, distribution, anything like that?
Could be any of the above.
Okay.
Primarily for playout.
And then is your company comfortable with CapEx versus OpEx in one particular fashion?
Oh, yeah.
Okay. Anybody else here wants to give some insights, or you can feel free to say I absolutely despise cloud because that's the reality. No? Okay, let's get started and then just see, throughout this process, anybody wants to chime in and provide some insights or additional questions. First slide over here, what is cloud? Cloud is really somebody else's data center. The difference is just instead of you go ahead and maintain and then pay the rent or own your own building and then rack up all the servers as a CapEx fashion, now you're going to have to start paying monthly recurring revenue to the technology solution vendor. The issue is, one particular issue is you need to be big enough to grab attention from AWS, Microsoft Azure, or Google, because they're going to treat you as, one of the millions of customers over there in that data center. And when you go off the air, they probably don't realize the importance of that and how it actually impacts you. They will just look at you, how much you pay on a monthly basis, and then just, put you in a tier 2, tier 3, or even lower grade. So that's the reality. But at the same time, if your company prefer an OpEx model, or you are a relative startup, you don't have a lot of CapEx to initiate a new business, this is a very valid way for you to minimize your risk and then get started. And of course, if your company is always chasing after the latest trend, cloud technology has got enough buzz within the industry. So if you already have some on-prem arrangement and then you need to migrate to the cloud, how do you do that? There are two fashions. One is just lift and shift. What does that mean? Today I have this application running on Windows, on my own servers, or maybe it's on a VM. I'm just going to install on AWS VM. That's about it. Exact same software stack, move it over there. Nothing changes. I minimize the workflow for my operators. Things go as usual. The other approach is called cloud native. In regards to cloud, one of the advantages is scalable, right? So if you actually start sharing your resources with other customers or clients within the same cloud environment, the benefit of completely rebuilding your software stack to be cloud native, then you get to run more efficiently and you're less dependent on the operating system and the acceleration services. For example, the recent CrowdStrike instance impacted the Windows. So all your applications on Windows were taken offline. If you actually completely reinvented your software to be cloud native, you wouldn't have that same level of risk. So for many of our customers that are still running some legacy software on Windows-based applications, they were impacted by this issue, but mostly for our cloud customers or the customers still running appliances, but with cloud-native architecture, they were not impacted at all. So again, this is what lift shift is. Exact same application, database, operating system, copy over to somebody else's server. Cloud native, from the monolithic architecture to the left side of the window, that's the same fashion as a Windows application or Linux application, but exactly the same. You need a basic framework and additional services, and everybody's intertwined and connected with each other. Now you're breaking down into containers. So each container is responsible for one particular functions, and another term for container is called microservices. Of course, the UI becomes the orchestration layer to actually issue the command, but the actual function is performed by little pieces that are not dependent on each other. So today, if I want to completely add some new features to my database, I only need to look at my database microservices, and I don't care what others are doing because they're not dependent with each other. So with that, the pros and cons of both fashions are pretty obvious. With lift and shift, the pros is that I don't need to do any reinventing of the wheel, so it's minimum work for me to move the application, and as a result, it will be a much faster migration and deployment. But the cons for that is that you're not taking advantage of the native features of the cloud platform. Essentially, your AWS bill at the end of the month is going to be significantly more expensive versus if you actually remodified your software to be cloud native. And if we go to a partial refactor, that means a part of your applications were just directly lift and shift, and then the other part were rebuilt to be cloud native. Then it's faster migration because you still got 50% efficiency there. I mean 50% I would say benefits of directly copy and paste. And the cons is that you're only taking advantage of 50% of the benefits of the cloud, and essentially it's still more expensive than completely refactor at the very bottom of the chart. I don't think I need to go into all the details. So the reasons why you want to go to the cloud, if you look at the traditional model, everything is on-prem, one-time CapEx expenditure. So it's going to be a lot of money you need to spend. For example, in the traditional workflow, you need all these switches, you need all these playout servers, automation, encoder, receivers, and everything. And many times you'll you purchase some expensive pizza boxes sitting there, and you probably only need to use it once a year or something. 99% of the time they're just sitting there and burning because you don't want to turn it off because, you know, who knows, and then during the most important event of the year and you try to spin it back on, it's not powering on, and it's a much bigger problem for you, right? So as a result, it's only horizontally scalable, and there's a high maintenance cost associated with it. You need to worry about power and cooling, or maybe 24/7 staff, or leasing a space, and so on. Now, if you move everything to the cloud, it's virtually no CapEx or very low CapEx because you still need the on-ramp process from your data center or maybe even from your existing facility, on-ramp and offload from the cloud. And it will become highly scalable because you're essentially sharing resources, and you'll be able to grow exponentially on that. And traditionally, if you're just paying for, you know, you're grouped into a large group, so your maintenance cost is traditionally lower than if you're just maintaining your own hardware. The same principle can be applied if you just want to judge between private cloud versus public cloud. with all these points, it's pretty obvious why the broadcasters has been saying no to the cloud. Is there's a cost consideration. You might only need to get onto an affordable payment plan on a monthly basis, but at the end of 1 year, 2 years, you're gonna see, oh, all these add up exponentially higher than what if I just went ahead and purchased my own hardware. And also, it's typically within all the media companies, the CFOs and the finance team, they have a preference on CapEx versus OpEx. So that's another challenge that typically the local director of engineering are facing when they're trying to convince the upper management for embracing technology, cloud technology. The second point why we do not want to go to the cloud is quality control, because you don't really have full control of your compliance and interoperability anymore. And many times it's dependent on the mercy of whoever is your cloud provider. The third concern is security concern. Essentially, all of your services are now running on public cloud 24/7. There are, services that guarantees that they have security companies essentially issuing all these updates in a timely fashion, but to you it's a black box. You don't know when they're applying all these and whether they're caught up to date, rather than you yourself take care of all the security updates. Fourth is content ownership. With everything on the public cloud 24/7, you don't know, maybe your copyright content is somehow being hacked or being shared with somebody else that you do not want to share with. Fifth is, in addition to all these cloud egress and bill that you're facing from AWS, you still need to worry about your connectivity to their closest data centers. So you probably have to contract with some third-party services, or even sometimes embrace 24/7 monitoring, eyes on glass to report connectivity outages. So that's another expenditure for you, and many times it's another OpEx for you. And the very last point is that, everybody still has some legacy stuff from 5 or even 10 years ago, and how will we be able to ensure they're still compatible with all these cloud connectivities, all these new devices. And many of the manufacturers probably has already gone out of business, or maybe they just simply saying, no, we're just stay on, commercially off-the-shelf servers, or even proprietary hardware. So now it's pretty obvious that, broadcasters, I think for the majority of us, are not embracing cloud technology. But at the same time, you probably say to yourself, oh, I don't want to be missing out with the latest technology. I don't want to become irrelevant to what's happening in the rest of the media entertainment industry, right? So how can we ensure that even though we're not completely migrated to the cloud, we're still taking advantage of many of the benefits that's associated with it? And this is where we actually decided our strategy. It's based on the feedbacks, and then look at the reality that it's going to take a while, or maybe it's never going to happen for the broadcast to completely migrate to the cloud. How can we actually modernize the broadcaster's infrastructure and a software strategy? So we come up with this common cloud-native software foundation. So about 7 to 9 years ago, Harmonic spent a lot of money, completely took a different direction with all the vendors in our space, that we completely rebuilt our software stack to be cloud native, called VOS 360 SaaS services. That one includes, everything from ingest, play out, and encoding and delivery, both streaming and broadcast. And once we go through all these very painful growing pain process, we simply just port over that same software stack onto commercial off-the-shelf server like HP or Dell servers or Nutanix server, whatever you're comfortable with. So it's the exact same technology that we put into our XOS product. So for some of you who might already have some exposure to XOS, every time you need some new features, we will just simply just cross-check with VOS 360 platform. Maybe they've existed on that platform for a long time. So all we need to do is make sure it's validated on XOS and it's compatible with, like say, SDI, ASI, all those concepts that does not exist on the cloud environment. And many times for our VOS 360 customers, for example, the Apple TV is on VOS 360. The entire NBC Peacock is on VOS 360. Bally Sports, all the regional sports network, and both in its previous shape or form or after it's separate into many of the little regional sports networks, many of them are VOS 360. Many times they actually require broadcast-related features, and then we just deliver the good news. Great. We actually already delivered this on our XOS platform, so all we need to just validate for you on VOS 360. And with that, we can deliver everything on our VOS 360 cloud if you decided to go all in with cloud technology, or to the far right, if you still want to embrace appliances, commercial off-the-shelf servers, we simply just put the same software stack onto XOS, and we still sell the very traditional Harmonic Omnion Spectrum X playout servers. So these are still one of our largest revenue generators. And if you are considering private cloud, maintaining your own data center, but you want a cloud-native technology software stack, which your DevOps are responding for, Kubernetes maintenance and updates and patching, API calls, everything, we provide the exact same software stack to be installed in your private cloud environment. So with that, we think that's how we actually guarantee customers from all aspects are happy with our solution. So now let's focus on how our XOS are taking advantage of all the cloud-related benefits. First benefits is that it will be so much more efficient and lightweight. If you just look at other vendors in this space, even as of today, vast majority of them are simply just squeezing their legacy monolithic application into a VM or into a container and claim they're cloud native, but that's different from our strategy. They're not taking advantage of all the low CPU utilization, low memory usage, and a much faster boot up time, because essentially they did not get rid of that extra layer of operating system on all the containers. So that's why in various shootouts you will notice that if we show up with 1RU commercial off-the-shelf servers, we're able to deliver twice or even 3 times of the density in comparison to the competitor. That's simply because of the efficiency that we gain from VOS 360. So for ATSC customers that typically want to maintain ATSC 1 workflow, as well as want to spin up new ATSC 3 services, the XOS large, that's called large V2, we call it V2 because this is the new HP Gen 11 server cycle, even with the most stressful HVC services, you can run 10 of them, 10 HD 1080p services on 1RU HP servers flawlessly, in addition to your existing ATSC1 services. And for our customers who actually want to play with our latest features and then aggregate more services or perform dense UHD projects, you can simply just utilize the XOS extra large V2 based on the latest AMD CPU technology, and you can run 5 HD HEVC services simultaneously. And all these metrics are based on our premium VQ. So if you actually have some tolerance between premium VQ versus standard VQ, you can actually even spin up more services without having the server overloaded. Then we move over to the left. For more affordable solutions, we have XOS Small that typically customers are using as a IRD receiver that can still perform transcode, that can still perform some lightweight tasks. As you can see, even with XOS Small, it probably fits many of the ATSC stations that are simply still fulfilling ATSC1 workflows, because I can run 12 SD services or 4 HD services there in MPEG-2. And then XOS medium is just one step up from XOS small. That's like a hybrid between, before you actually want to go above to the standard XOS large. Maybe you have some corner use cases and you can take advantage of the medium platform. But the hardware cost basis between all these hardware platforms are, minimum, sometimes just $1,000 or $2,000. So we're actually seeing vast majority of the customers simply wanting XOS large, because that guarantee that in the future they can even put in additional SSDs to do playout in addition to encoding. And we even see some customer who are serving a head-end distribution purposes. They will say, oh, just give me the extra large because it doesn't really cost me more in the long run. So this slide, I think many of you are very familiar with. I think you've seen it from various places, sometimes from me or sometimes from various Harmonic webinars. And the items that are highlighted in blue are the ones that the competitors simply cannot deliver because they are not really taking advantage of a cloud-native approach. But one step further is that I even put a highlight on many of these items just to simply show you that it's thanks to what we originally developed on VOS 360 that you're enjoying all these functions on one RU server. First of all is on our ATSC1 StemMux, you can directly output SRT. You don't need a media gateway. So that's additional, cost saving for you. And because VOS 360 itself is an end-to-end workflow, you can now do playout for the very conventional Charter, Comcast split signal, or your own customization for local ad insertion. And this is all because it's the same software stack from our end-to-end VOS 360 cloud-native technology platform. And moving over to ATSC 3.0 front, ATSC 3.0, of course, from the consumer side, it's meeting its challenges. From the broadcast side, it is still moving forward ahead. And then one of the latest hottest topic is how you can actually take advantage of all the NRT data casting. So with that, you definitely have a need to shrink your StemMux size so you can give out additional bandwidth for NRT data casting. And when the particular event is over, you want to go back to its original shape or form. So because of the VOS 360 API-driven cloud-native architecture, we're able to deliver the exact same interactivity on XOS. There was a press release that we put out last year with Digicap, a Korean company that's actually playing a very pivotal role in ATSC 3. They were able to simply seamlessly interact with XOS to in an interactive fashion to modify the StemMux size to leave room for data casting. Next item is virtual channel implementation. So many of you are already familiar with that. Is the other name for it is broadcast IP for ATSC 3. It's typically for stations who are left out of the channel sharing game that still want to get onto ATSC 3. You can still have your video and audio dash on the internet and then asking whoever is hosting the over-the-air transmitter to give you 60K just to simply add your channel table of contents, MPD, into the list of programs. And then for the viewer at home, as long as their TV is connected to the internet, it's seamless to them. They thought they were just watching over-the-air programming, but essentially the video and audio, all the big chunks are coming from the internet. But if for any reason they lost internet connectivity, they still have the channel major and minor number, the channel station call letter on the top left, top right of the screen to fulfill the FCC requirement. And last but not the least, because with VOS 360 accelerating all the streaming directions, it has a built-in origin taking advantage of all the cloud provider side. We actually put a mini origin into XOS for various OTT platforms to pull and push. So typically in your station, you probably have a dedicated ATSC encoder, probably have an OTT encoder. You probably were asked to provide a transport stream to feed the OTT encoder where they will re-encode and then give you dash or HOS, or simply just being pulled from various OTT platforms. It's no longer necessary. We actually have worked with many station groups to simply aggregate all these workflow into XOS. So the benefit is not just aggregate all these functions into one RU box, but we're able to provide much higher qualities than those players in the OTT world, such as Elemental, DVO, who are not in the encoding business. And this is actually a more detailed illustration of using XOS for live origin. As you can see on the XOS, we have the streaming and broadcast encoding function. We then package into HLS dash, whatever format you need. And then we have the origin here on the server. And to the bottom of it is your traditional transport stream StatMux serving your ATSC services. And then to the upper side, you have various platforms such as BitCentral. Simply just do a pull from it and it essentially fulfill OTT services. And this is a more detailed illustration of the playout capability of XOS, and this is just the intro slide. Broadcast and the streaming will fulfill all with one playout functions. So with all these functions aggregated, XOS, thanks to the technology, is not just an encoder. It's not just a packager. It's not just a decoder. It is also a playout server. And because of that, XOS, the full name for XOS is not XOS encoder. It's called XOS Advanced Media Processor. As you can see, for playout functions, right, I'll just simply take in live sources, with being SDI or transport stream over the IP, and I'll take in your clips, your graphics. They'll just be FTP'd onto the additional SSD drives on the XOS. We'll go ahead and ingest it, and there is a playout monitor UI that's built in to the XOS. So if you have a preference to using your external automation system, you probably don't need to deal with this UI. But if you want to save additional money, you want to further aggregate your workflow, further consolidate your operational cost, you can simply take advantage of the built-in automation UI within XOS, and then your traffic system will simply just send playlist to XOS, and XOS will intelligently feedback the Azuran to fulfill your business requirement. And then once we have the playout function completed and with the graphics inserted, we'll just natively move to what XOS was originally known for, being an encoder. We'll perform the transcoding services. We'll get the EASNet messages from DASTAC, and then if you still have a preference of SCSI-18, but nowadays, for broadcast, SCSI-18 is irrelevant, but we still support that protocol. But the most popular protocol for EAS is EASNet from DASTAC. We'll receive the EASNet messages to do the crawl, and it will directly fetch the PSIP from various providers. If you're a commercial station, it will be Titan TV or Grace Note. And if you're a PBS station, it will be Myers ProTrack. All these vendors have been vetted. You no longer need a Triveni or DTVI PSIP generator. You no longer need to pay your subscription services. Everything can be done from the encoder. So after we go through the encoding cycle, we go ahead and just deliver to your traditional IP or ASI output for ATSC 1 services, dash output for your ATSC 3.0 services, and transport stream over IP to feed various MVPDs because they require split signal, right? They require various SCSI triggers that's coming from your playout system. You no longer need your purchase additional playout systems to link to your encoder. Everything is natively generated within XOS. And if you need to feed all the various OTT platform for streaming purposes, you just simply create another output from XOS. So in a nutshell, XOS is your ATSC 1 encoder. It's your ATSC 3.0 encoder. It is your playout server for split signal and local ad insertion. It is also your OTT streaming server. So it's really a Swiss Army knife at this point thanks to the cloud native technology we've developed on VOS 360. And one more additional benefits that I want to get into more detail is regionalization. So what do I mean by regionalization? That means you actually have your corporate or central head-end mass control send out a base linear TV content with this particular order, commercial breaks with a Titanic movie clip in between, and then a baby commercial, and then going back to the Titanic movie, right? So for your particular station 1 in Columbus, Ohio, based on the SCSI trigger that's coming from upstream, I will go ahead and replace the Titanic movie here with a local rugby game, but I will keep the same commercial. And then once the commercial break is over, I'll go back to the rugby game. So essentially in region 1, we're replacing the actual main content. And then in region 2, such as Cleveland, Ohio, right? We want to replace the Titanic movie with another movie, which I cannot tell from this thumbnail. But one step further to that is instead of the national baby commercial, I have a local advertiser who's willing to pay for more if I'm able to, just make a more local commercial ad insertion, and I can do that. So not only am I customizing on the main content, I'm also customizing on my commercial content, essentially bringing a much higher return on investment. And the secret sauce to do that is XOS. Based on that workflow, you can create a TV channel from file, from live sources that's ready to air, and it will just insert those rich HTML graphics for you, and we'll go ahead and replace all these ads and then blackout programs per your personal preferences. And then one step further to that is that if you ought to do all these different customization as I just laid out before, what you need in Columbus, Ohio, which is affiliate number 1, or Cleveland, Ohio, which is affiliate number N right here, you first need an IRD to receive the signal from your main head-end. And then you need a switcher to switch between existing content, pre-recorded content, or national content, and your local news cutting. You will then need a playout server, and here I'm just simplifying it. I did not let you put in additional equipment like automation servers and graphics switcher and all those in here. Let's just call it the big playout server here. And then after playout, you will feed that baseband signal to your ATSC encoder for ATSC 1, ATSC 3. You will feed another playout signal to your OTT encoder to fulfill your streaming needs, right? With XOS, that's just one box for you. That's the power of a cloud-native architecture, end-to-end workflow. And we're constantly further developing on that. What depends on whichever creative workflow you're thinking of. That's the benefits of scalability from a cloud-native architecture. That's an approach that if you just look at the industry, no other competitors are able to actually mirror this workflow. They might have advantage sometimes in 1 or 2 particular corner cases, but in regards to completely keep adding to your existing media processor, it really depends on what approach you took at the very early stage, which is 7 to 9 years ago, where Harmonic actually decided to go in and then go against the industry trend and then reinvent the software to be cloud native. And because of cloud native technology being embraced so much in streaming side, and streaming always has that never ending mission to catch up on the latency on broadcast, we are also able to provide very low latency on XOS, both on OTT streaming and on broadcast. And these are some, impressive metrics that we get from real world experiment so far. And it will be the same web UI as VOS 360. So if you were ever in a situation where maybe your corporate is incorporating VOS 360 for cloud-based playout, and all the stations are using XOS to receive that signal, doing further customization, it will be the same UI for the operator to look at. So there's no learning curve. You configure monitor without external management system, and you're looking at a consistent UI. Another benefit from cloud technology is that we don't need to develop our own stress meter. We can simply take advantage of the cloud native CI/CD community. They have this tool called Kibana, actually provide very accurate real-time metrics of CPU loading density numbers. We'll just simply rely on them to keep providing updates on that, to assess real conditions, to provide insight for capacity extension, and to check stress evolution in time. We can focus our energy in developing new features and further optimizing our VQs. Here's what I talked about. The API it's RESTful API and easy to test. We're not going to just simply hand you a 500-page PDF file for you to write some Python script running on third-party machines and just cross your fingers to hope it works. We provide you a fully interactive color-coded field for you to perform your tests, and it will be able to catch simple syntax errors and tell you whether this will perform its desired functions or not, so you can further optimizing your API calls until it's ready, then go ahead and apply to the real deal. And because everything is so fluid in the cloud world, the licensing are being tracked from it, depending on whether you're, well, of course, in the cloud world, everything's connected to the internet. That's how license is being tracked. We simply just embrace the same mechanism onto XOS. So if you're willing to connect your XOS to the public internet, we'll simply just get your license reading from there. But if you just prefer to keep it isolated from the internet, it's just a config file we'll just assess once a year from you. So what's the benefit carrying around with this innovative licensing we're talking about? Everything will be trust-based. That means if today you only purchased 3 encoding licenses and then all of a sudden your boss came to you saying that for the election, I need to spin up 2 additional channels, and you cannot get a hold of Harmonic salesperson, just go ahead and simply spin up those services. There is no software mechanism that's putting a warning message saying you're now using 2 more services than what you purchased. I'm going to take you off the air within the next 30 minutes. No, it will just keep running as long as your CPU can support it. So you gain that flexibility. Everything is trust-based. We will simply just get that reconciliation later on. And if we figure out it was really just you testing, can I run additional services on here? And then you turn it off after 2 or 3 days, we don't even bother with it, right? And then if we figure out that actually you decided just to keep running 2 additional services moving forward, then we'll just engage you to see how we can better support your business use cases from that point on. And maybe, there's new avenues for you to actually migrate to other platforms, or maybe make modification to your existing workflow to more efficiently taking care of your resources. So the sum of it is that you can add new channels or new features, which is capabilities, immediately, anytime, without the fear that you will be taken off the air. And the very last slide, well, not the very last slide. The next slide I have right here is, I think many of you are still hanging on to the legacy Harmonic X2S system. It's still doing its fine job for ATSC1, and it still has the capability to generate HEVC transport stream to contribute to the ATSC3 Lighthouse station if you're ever in a channel sharing program, but not being the Lighthouse station. Here's the list of X2S, the things that XOS can do where X2S cannot do. If you're interested, I even got another slide that put out the competitors that tells you what they cannot do. But essentially, the theme around this is that because X2S is on the old architecture, the monolithic approach, just like everybody else in the industry, there are so many things that it cannot do where XOS can deliver. And I don't want to bore you with individual features, but I do welcome to talk to me if you want to learn more specifics. There's actually one more thing that I want to let you know. The latest thing we're cooking is that we've recently made so many advancements in sports streaming on VOS 360, including live closed captioning generation for live games and live translation for audio. So essentially, it will be a speech-to-text operation if you're doing live captioning generation, right? And that's being embraced here on XOS, is that we actually receive a request from a major station group that's probably ranked top 5 station group in the nation. They live around XOS across all 72 of their stations, and they actually use NCI, National Caption Institute, for AI closed captioning services. And right now it's going through on-prem closed captioning encoders, and it's giving them 2 troubles. One is the support contract for the closed captioning encoder manufacturer keeps climbing up, and second, there's additional latency introduced once their signal goes back to the ground and then rely on the closed captioning encoder to merge into SDI signal into XOS. So for that, we're simply just directly interfacing with National Caption Institution or any similar protocol services that would just directly feed audio to them and then get the closed captioning data natively integrated into our input signal. So the benefit of that is that you can get rid of those extra racks of equipment for your closed captioning encoder. You can reduce your latency to be finally within the 4-second legal boundary required by FCC, and that's additional cost saving for that. It's for this reason the station groups is willing to pay for development costs for that. The argument is that they said, if I can save $1 million on that, I'm willing to pay for you $750K for developing this feature. And we gladly took up the offer. So in a nutshell, that's my presentation today. And let's see, it's 2:46. We still got a couple more minutes. So I have some live demos that I can show to you, like the latest things that demonstrate our capabilities. And typically these are shown at NAB shows or various trade shows or IBCs. But before we move further to that, does anybody within the audience have any questions or have any complete unrelated topic you want to discuss? All right, cool. Then let's go ahead and go to the demos, and hopefully there could be some additional topics being sparked along. So let's take a look at broadcast and distribution. That's what everybody sitting here is most related to. So there's the XOS latency. So one step further to what we just discussed is the latest thing we're cooking is called XOS. It's called dynamic frame rate encoding. That means for vast majority of the time, we will keep the frame rate at 60 frames per second. But if we detect a dull scene, and that's based on AI or machine learning prediction models, we will just intentionally reduce the frame rate to 30, 35, 20. And as you can see, during those time, to the audience, there's seamless transition, but the CPU usage is significantly going down. And that means by embracing dynamic frame rate encoding, we're able to provide 20% more density on the same 1RU server that we're enjoying today. And of course, you're able to lower your power footprint by 33%, provide a more greener energy. So that's what we're showcasing today. The good thing about dynamic frame rate encoding, if you remember a couple years ago, Harmonic is pushing to the industry very hard on dynamic resolution encoding that's flipping between different resolutions based on the scene complexity. One issue with that is that you will need the receivers, the TV manufacturers to go ahead and conduct all those interoperability tests. Even though vast majority of them did respond and said there is no problem, we still receive resistance from many of the small players who simply don't have the R&D resources to go ahead and support that. So that one is still sitting as one of the roadmap topic being brought up during various ATSC meetings. But this new dynamic framing encoding is completely independent from receiver ecosystem. So you can embrace it anytime you want. And if
if you are a content provider, typically your distribution of your content is through satellite, as seen here. Or if you're ATSC broadcaster, we've got like a regional, like say educational network distributing to various sites, and it will be terrestrial. So these two use cases are very similar to each other. All you need is just put an XOS at the affiliate, and you can go ahead and use it as a conventional receiver, or you can do play out with local ad insertion for both broadcast and streaming capabilities. And then we even have our DMS-X system, that is a network management system that controls and monitors all the IRD capability and status. It will be intelligently send the necessary schedules to the affiliate, and along with that, not only schedule, but the actual content from them to insert all the ads. So this way, everything is nicely monitored in a central dashboard for you. This will be something that you probably want to talk to your corporate if they were ever interested in such model. And same thing, if you want to go through the IP route, you can, take advantage of all these benefits. But moreover, we also have the VOS 360 for you if you decide to do further manifest manipulations onto this end. And with the cost of SRT output going down significantly, if your endpoints is more than 200 at this point, it is actually cheaper than satellite or terrestrial distribution model. Of course, terrestrial, you typically don't have 200 endpoints. But for satellite, if you're actually at the renewal time and trying to see whether it makes sense to pay those hefty costs to the satellite provider, this will be, we're more than glad to provide you analysis on that. And the demo video basically is just showing during main content, right, in region 1 and region 2, there's no difference. And then once we hit ad break or something, this is just to warning you, okay, we're about to go into ad break. And this is, our slate to tell you that. And then you will see that you can insert various ads during the ad break to further, optimize your ROI in a distribution model. All these is coming along with your XOS encoder. So you basically essentially originally asked for an encoder, and now it can do play out, it can do local ad insertion, it can do an IRD function, and then it can serve both your broadcast and streaming needs. And we're going back to the primary content, exact same content. And one other thing is, with VVC being actively added to ATSC 3 standard and then being the chosen codec for Brazil TV 3.0, we're gladly, providing further development on that. On paper, it's supposed to provide about 40% less, 40% efficiency over HEVC, but requires twice more CPU resources. But based on our control environment tests, in reality, so far, it's about 20 to 25% efficiency. So that means on the left, I'm running a HEVC service at 3 megs per second. On the right, I'm running a VVC service of 2.4 megs. So that's about 20% bitrate saving there with the same VQ. The use case is that if ever one day you want to be more efficient in ATSC 3, you can go ahead and embrace that technology. Or if you simply just need to create some mezzanine feed for distribution purposes, you can further reduce your bitrate to take advantage of your limited bandwidth. And if you're ever, more involved in your playout workflow, we still have the Spectrum X, Media Grid, all these nice stuff with the Media Center, very nice laid out UI that provides you, and Media Studio Live that provides you all these versatile playout functionalities. So at this point, you probably realize I've been talking so much about XOS playout, but then I'm still pitching Spectrum X. So what's the difference between them? So far, they're so similar to each other. The only difference is XOS, we do not have planned to provide SDI output from it. because the purpose for XOS, because it has encoding capability. Our slogan for XOS is you want to kiss goodbye to silo, right? You don't want a dedicated playout server. You don't want a dedicated encoder. I provide just one box that can just address both use cases all at the same time. Versus Spectrum X, it's still a dedicated playout server. It still has a lot of bells and whistles that XOS do not have immediate needs to put onto the roadmap yet. So if you're looking for a sophisticated, comprehensive playout features, many of our customers, after careful evaluation, they still chose Spectrum X as their playout refresh solutions. So it really depends on your use cases. Maybe Spectrum X is a good solution for your most important channels, where XOS is just for local ad insertion or for your DR plans. Then you can further, optimize your ROI in that front. And this is the XOS playout to delivery, as we were just saying. It's just that it will be so much more cost effective, because you don't need to purchase individual component anymore. It's as if you're running a end-to-end cloud service in one RU server in your own facility. And it has a nice built-in UI. One thing that, because in my past life, I was actually with Warner Brothers Discovery, and then, Omnion has a fine legacy of being a playout vendor, but once everybody else starts to get into channel in a box approach, Omnion kind of stayed in that fashion. And for that particular reason, when Warner Brothers Discovery went through the cloud migration for playout, they did not really choose Harmonic solutions. But once we started evaluating playout use cases within Harmonic, we feel the need that still provide as many built-in automation capability as well. So as of right now, XOS or VOS 360 playout has, I would say, 70 to 75% functionalities for all the traditional automation partners that we're actually just partnering in the traditional model. So it's really up to your specific use case. We'll evaluate and then let you know whether we need to bring in our conventional automation vendor, Crispin or Avaco, Florical and such. But for many cases, if you want to save that extra expenditure, I think XOS can deliver everything within one box for you. And this is just illustration that if you do want to move ahead with a dedicated Spectrum X workflow, and then you want to maybe put VOS 360 playout as your DR plan, the one automation server that you currently possess or the one you plan to purchase can control both through the API calls seamlessly. So as you can see, the VOS 360 output and Spectrum X output are identical, 100%. Any questions before we go further ahead? Yes, please. Yeah. Nielsen watermarking has been supported for a long time, even on the legacy X2S system. I probably shouldn't say that. Yeah. That's not ideal for the customer. They're talking about newscast. They don't want to delay it. Yes, that's the mechanism you could took. That's what we suggested before we came up to a solution, right? Can we intentionally delay the video? You can do that, but the effect is very limited. Somehow they still yielded about 4.3, close enough, but still not 100% legal. And then second of all, the business do not want to do that. Yes, but this latency we're talking about is between audio and closed captioning. That's the FCC requirement. Yeah. Yes?
You mentioned that you work with Crispin. What is your overlap features? I mean,
Like, say, the playlist control?
yes.
Sending over Azure logs. So instead of relying on Crispin to deliver to your traffic system, we'll just directly reach out to them and directly append playlist, directly create events on there. many other just automation. Because essentially, what automation system does, it's just issuing various API calls to the playout systems. So what we need to develop is just provide a UI to ease the workflow for your operator. All these functions are essentially it's already being conducted by the playout servers. It's really the UI that Harmonic for years has not really invested in, both for business purposes, because we don't want to piss off our automation partners, and second, that we want to focus more on providing premium VQs, versatile playout functions, rather than spending on UI. But, everything, for my personal liking, I think, there's a lot of business justification to further embellish our UI, and that's why XOS and VOS 360 Playout is in its current shape or form. We have so many customers, even large content providers, simply do not need additional automation system. And then as for broadcasters, why go broadcast? The reason MeTV, Me2, all these services is purely coming out from VOS Playout, and then that is actually in a private cloud environment. It's the same VOS software installed in their private data center without any automation system. Any more questions? Yes, go ahead.
When your AI closed captioning, is that a new feature?
It is a new feature.
You mentioned perpetual licenses. Is that like billed per hour or compute, or is that?
Perpetual license means one time. That's it.
So the closed captioning AI recognition is local to the appliance then?
So the AI recognition is being conducted by NCI. We're essentially feeding the audio to them, and they will do the speech to text and generate the closed captioning data, and then we'll take that data directly embed into video and audio. We're not participating in AI predictions. Even in our VOS 360, all these we're partnering with AI agencies because that's what they're good at. We're actually just making sure the frame accuracy, and then we're making sure the interoperability, and then providing the premium VQ.
Basically, that's just a hook into.
Direct integration without third-party equipment, yes. The reason for NCI, because everything's already present, it already exists on VOS 360 with Microsoft OpenAI, the most comprehensive technology. We asked that particular customer, but they said NCI is actually the gold standard in broadcast. The reason why is they have lobbyists that can face in front of FCC. Any more questions?
I got a quick question.
Yes.
On the other side, I got a production studio. We do live switching on remote. Get rid of TDs and all the
Yeah.
other things and put it in the cloud. But if I come with you, how would you guarantee me the latency? Or do you do that?
I hate to tell, unfortunately, remote production is not the field that we're currently playing. Harmonic was in the field a couple of years ago, but the principle is that when we analyze all the other market share, we're the absolute dominant, and we decided to not putting much effort into the area where, other players are playing, so, yeah. But if you're interested in learning more, I can certainly loop in the account manager. Maybe we still have some additional, because there are still customers utilizing Harmonic equipment back in old day when we were investing into that field. So maybe there are some additional guidance we can provide you on who you probably want to seek more recommendation from. And then, this voice cloning is what I'm talking about.
Well, he's broken it out, a few times in years past as DA easily controls the tip. And off we go. Little double team pressure.
So right now it's the native audio, right? It's being sent out OpenAI. And you hear that it now has changed to Spanish in real time. So the live closed captioning is essentially half of the first half. This is speech to text and text back to speech. Yep. And for that, our partner is Camp AI and the LingoPal. And live sports event basically is just that when you're embracing a cloud technology, you don't need to worry about running that service 24/7 as a linear channel. You can just schedule a particular event if you think you can increase your IOI over there, essentially provide you more flexibility in terms of spending on that. You can just, keep it black for most of the time, and there's a intuitive GUI for you to say, at 2 p.m. I want to spin up that NFL game, and 5 p.m. I'll spin it down. I don't care about the rest. That's another flexibility from cloud technology, is that you actually get more control of how much you want to spend. And then you can even go further than that. Like maybe you want to say between 12 p.m. to 7 p.m., I want to run my event, but maybe it's only 2 p.m. to 3 p.m. where I want a premium VQ on that. Then you can increase your CPU usage, probably charge more by AWS during that period, but for the rest of the period, you go back to the next grade to save on your cost. Personalized fan engagement, this is basically just, you can do a ChatGPT fashion, ask it questions if you're, say, 30 minutes late into the game, and then ask it, what is the game about, was there any goals and such. Yeah, I need to go back to live. Yes, this needs to be live in order to interface with ChatGPT. Monetization, we provide in-stream advertising. That means it's like, say, in a basketball game, if there's a stoppage time or free throw, your audience is probably going to be taking a bathroom break or something, but they don't want to completely switch to another channel. So for those who are probably just looking at their phones, but still having the other eye looking at the screen, you can actually perform in-stream advertising with the free throw still going on. This is so long. I need to find out where it is. But essentially, it's just that the field. What's happening in the field is gets squeezed back into one tiny screen to the left, and then I'll just provide ads into another squeeze box to the right. Essentially, you just get more return on your investment on that. Low latency SSAI, that's something, a real demonstration of how we're able to deliver. Many of these are live demos, so depends on the bandwidth we have in this conference room. You might see some delay, but I'll try to see if I can just use my hotspot at our exhibition booth, and then if you're interested in checking out the actual latency from our, demos, and then you can go ahead and do that. And server-guided ad insertion, in the ad insertion world, we are more focused on server-side ad insertion. That's actually what we're good at, and that's what all the big networks are using. But there's also the traditional model of client-side ad insertion. And lately, there's been a talk about hybrid is server-guided ad insertion, where the ad insertion is still happening on the server side, but it's being guided by the set-top boxes. And so the purpose of this demo is just educate our customers what that's regarding and how we can be compatible if they want to choose that business model. This was a hot topic during IBC, but how quickly things are shifting. Right now, there's a big criticism around server-guided ad insertion. Maybe it's not going to become a thing. And with that, that's everything I want to present to you today. But I welcome you to come to our booth to learn more. Thank you.
Thank you, Jing, for a great presentation today. We're going to take a 10-minute break. Our next group of breakout sessions will begin at 3:20. The session in this room will be automating video production using AI. And down the hall in room D280 will be duties of a chief operator. Thank you for coming out today. Thank you.
Thank you, everyone.